Hi everyone, I'm going to be going over question 67 from the chapter 6 bingo questions. And this problem is talking about someone getting rear-ended in a car and the whiplash that happens. And so it wants to know, it's first of all given that bones in the neck will break if the energy is greater than 8 joules of the neck. So energy like onto the neck. It also gives us that the mass of the head is 5 kilograms and the crash time, so the time that this all takes place, is 10 milliseconds. And so in part A, it wants to know the greatest speed that the head can have to move forward without the bones breaking. And so since we know that our 8 joules is our maximum, we can use our energy equation, which is equals 1/2 mv squared. And we're solving for the velocity at 8, since that's the very highest amount of energy that can occur without those bones breaking. So let's solve this equation for the velocity. So multiply that by 2, we get 16 over mass So it's just a simple question, we just rearrange it, solve for the velocity, and that equals 1.8 meters per second. So that's the very fastest that head can be moving forward before the bones in the neck break. Now the question also wanted it in miles per hour, and so we do that just through our conversion value, and so each meters per second equals 2.237 miles per hour. So when we multiply that out, we actually get an even 4 miles per hour. So that's the very fastest that whiplash can occur without the bones in the neck breaking. So that's it for part A. We'll erase a little bit, we'll write the 1.8. So that's it for the first part, but now it wants to know the acceleration. So it says, what is the acceleration of passengers in part A? And then how large a force is acting. So it wants the meters per second squared, the acceleration, but it also wants the g forces that are acting. So to do that, we'll use one of our lovely equations. So we know that the acceleration, its fundamental definition is the final velocity minus the initial velocity over time. And so we know that that's equal, of course. So acceleration equals the initial the final is 1.8 meters per second. The initial is 0, and the time is 10 milliseconds, 10 to the -3 seconds. And so we do the math here, we end up with 180 meters per second squared. And then to solve for the g forces, we just take the 180 meters per second squared and for a G-force, that's 9.81 meters per second squared. So meters per second squared cancel, you're left with G's, and that equals 18.4. I don't know if it's big or little g's, but we'll just say G. So I found that interesting because at first when I saw like 4 miles per hour, that doesn't seem very fast, you know? Like, I mean, maybe it is, but I guess I've never really thought about it in that way. But when you look at the acceleration, that head is moving 180 meters per second. You know, that's accelerating like crazy in 18.4 g-forces. That's something you don't want to mess with. So hopefully you learned something from this problem, and I'll see you in the next video. Thanks for watching.